Live from the Icebox Studio in Montgomeryville, Pennsylvania, it's the Bill and Corey Show.
I'm Bill.
And I'm Corey.
Oh, we got some feedback there in the mics. Okay.
There we go.
Oh, okay, we got the speaker thing figured out. Okay, that's a new year.
It's a new year with new television.
Welcome back. If you weren't dozing off at the beginning, you saw a new intro video. Thanks to the digital marketing group that come up with that. It was Corey's idea for the theme of it, and yeah, it was a really good job. I enjoy it.
Shows our products a little bit more than...
Yeah, it does. Yeah, you don't get the cool drone shots and stuff. But,
yeah, because we don't actually sell the gases here like that video would
no,
suggest.
No, we don't. Well, the first question today is for me. It's about someone's looking for a switchover for hydrogen sulfide. That's gas use, not liquid use.
Well, this actually makes sense because as we switch over to the new year, it is fitting that our first question is about a switchover. So don't forget to switch over your calendars.
Yeah, that's good. We didn't even have to prompt you on that. Okay, this is our standard switchover. One of our standard type switchovers. Doesn't have the flex hoses on it. It was an RMA. A customer wanted something to be modified on it. Maybe put different flex hoses on it.
Yeah, I never know.
But anyways, you think hydrogen sulfide's got a vapor pressure of 250-ish psi at room temperature, which would work fine with our switchovers because they're typically 200 psi switchover pressure. But it's a liquefied gas, so it's got a vapor pressure which is temperature dependent. So you want to put up the first slide. There we go. So this is a vapor pressure temperature chart for hydrogen sulfide, and we got this out of the Matheson Gas Data Book, 6th edition, which you can get from our online store for free, or you can also download it. So this shows you here, if you look at in the red, this is in, people doing these vapor pressure charts, it's nuts. They like to use complicated highfalutin stuff. So they have temperature in degrees Kelvin.
Makes it look fancier.
It looks fancy.
It looks more legit when you use Kelvin.
Kilopascals with 8 million digits.
And then you had to put the 50F on there and just make the chart all.
Yeah, so I just, 283.15 Kelvin. You have a really accurate thermometer. It's 50 degrees Fahrenheit. So you get did 50, 70, and 100. So it's
What's
70.
it in Rankine? Did they have the Rankine on here?
No, I don't know.
No, they didn't
do
do
that. You could do
one.
all sorts of things.
Okay.
So anyways, so at 70F, it's 250. But if you cool down at 50 degrees Fahrenheit, it's 181. So that's below the normal switchover point. And then if it gets a little colder than that, and this could happen, you have the cylinders outside in the warehouse in January, and you bring them inside to hook up the switchover.
Or the heater breaks.
Yeah, the heat breaks. Oh, geez, you shouldn't even go into work. So the vapor pressure could be lower than the switchover pressure, then it wouldn't work properly. And also, if it gets hot of 100 degrees Fahrenheit, it's going to be up to 382 psi. So that's why a normal switchover won't work. Now you want to show the, and I want to get into vapor pressure curves next too. You want to put up the next slide. Now this shows, it says ammonia on it, but this is a vapor pressure curve we got from somewhere. Well, it has the reference on there. A lot of times you see vapor pressure curves that are like this. It's a logarithmic scale, and yeah, good luck trying to pinpoint exact pressure on that thing. Because they also put it on, this is on PSIA, kilopascals, absolute.
Oh, it's absolute.
Degrees Celsius isn't as bad as putting up Rankine or Kelvin or something like that. But it can be, they're scientists, so they want to be look like they're smarter than everybody else. So they make it, but
so that's why they made it in a logarithmic scale. Because
yeah, it's a logarithmic scale. Well, it's easy to read the code.
I know it is, I know.
But it's hard to kind of pick out the temperature you want and stuff. And then you want to put up the next slide. Show it. Next slide. There. Oh, no. Wrong slide.
Uh-oh. Technical difficulty.
Yeah, technical difficulty.
Maybe it's the slide after. Maybe
That's
you go
okay.
2 slides ahead, it'll get you to your side, and you go 1 slide back.
No, it doesn't matter.
Okay.
The other slide showed it was also from the 6th edition, showed like little grid lines between it, so it was a lot easier to read. which would be nice if you had, minor grid lines in there. So we'll get back to this. So anyways, so this isn't going to work for hydrogen sulfide because of the vapor pressure changes. And a lot of low vapor pressure gases we use, I don't have one made up here, use a low pressure switchover, we call it LPX switchover, and they're mainly for liquefied gases with lower vapor pressures. So that would be a different kind of setup. We'd have a 3-way ball valve and another regulator in there set at a specific pressure. So in this kind of deal, we would have, we'd probably have it set up to be about 100, 120 psi, something like that. It depends on your delivery pressure.
Would we ever base this on something? I mean, if we talked to the customer, like say they're in Arizona, would we worry about something like this, or is this something that?
No, because it can get cold in Arizona too.
Okay.
But and it's really, you got to kind of set things up.
Okay.
So, yeah. So we really need to know delivery pressure, because if they really want a high delivery pressure, then we would switch over to what's called a vapor pressure VPX switchover, which looks at the difference between pressures of the two cylinders, and that only works when they're isothermic, and that's a little bit, I don't want to spend the whole show trying to explain all that stuff. So we can do something, we just can't use our standard one. So that's it for that. And we go on to our next question.
To another vapor pressure.
Another vapor pressure one. That seems to be the one. And we're going to pull one of these.
This is our special ammonia.
Yep. And this is, yes, a customer had a question on why is there a 3,000 psi inlet gauge for an ammonia regulator, and ammonia has 115 psi vapor pressure at room temperature?
Well, and you can correct me if I'm wrong, the CGA 660 can take 3,000, correct?
Yes.
And that is,
yeah, the 660 CGA is rated for 3,000.
Is rated for 3,000.
They could have probably 660 or 705 are the common ones for ammonia. It's also rated for 3,000.
So the 3,000 pound gauge goes on there. So that's just typically just for safety things, because you can use this for more than just ammonia with the 660, correct?
Oh yeah.
Yeah. So even though it's for this one, this one specifically for ammonia gas, the CGA fitting on the outside could be used for different gases that could get up to 3,000 psi, or I guess 22 to 2,700, wherever they fill it up to. So that's why. However, we have our fancy pants modified regulators, or -S regulators. And in fact, I actually did this for a gentleman just yesterday. I wonder if this question's related to the gentleman or not, if he asked it 2 ways or not. But he called in and he said, why do we have can I get a smaller gauge on there for ammonia? I said, yeah, of course you can. If you do a -S, you end up getting a 0 to 300 PSIG regulator. Ammonia is another one of those gases that fluctuates with temperature.
You want to pop up the chart?
Yeah.
That next chart.
Yeah, there we go. There it is. There it is. The gentleman himself said his pressures were running between 80 and about 125. And so as you can see down there at about 100 degrees, you can get close to 200 degrees or 200 PSI. So we don't really want to we want to keep it out of the range of possibilities. So at 300 PSIG, I doubt you're going to get above 120 degrees Fahrenheit.
You're not getting out of 120
So just to be safe, we did a 0 to 300 PSIG gauge on it for him.
And this chart is actually, I found a chart that's in Fahrenheit and PSI.
Wow.
Us people in America can understand. Non-PhD scientists. So you can buy -S regulators.
Yeah, -S regulators, modify. We can put different gauges on it, and like I said, just did it yesterday, and did the -S actually in the same day that he talked to me. So that order was done in 1 day.
Yeah, that's what's kind of nice. We can do modified regulators very quickly. We're set up to do things quickly. So. Okay, next question is also for Corey. Are the bonnet vent holes in a pressure regulator oriented in the same direction?
No.
No. Okay, next question. Now we did. And the bonnet.
Yeah.
No, this isn't the one we're looking at.
No.
Yeah, we got some. Don't look at the gauges.
The gauges are just there just to give you an idea of how the regulator looks, because we had the gauges off at first. We're like, doesn't give you a sense of what it's supposed to look like when it's when it's naked, essentially. So we added some gauges to it, and I don't know if we want to zoom in. You want to zoom in on Bill's?
Yeah, do your zoom in camera. Okay,
yeah. So if you can see right there, that piece of tape right on there is the bonnet vent hole. Now we put a little piece of tape on there because depending on what gas you have, most of the time you don't care if it's nitrogen, it'll blow the sticker off and just vent out into atmosphere, which typically isn't a big deal.
Yeah, so that's on the near the low pressure gauge.
That's
there.
near the low pressure gauge right here. And then, go
this
ahead.
one, I'll show this one. This one seems to be oriented over on this side.
This one right here, oriented near the high pressure gauge. As you can see, it's on this side.
Oh, yeah, this one's also.
So if you look at it, it's over here. So,
yeah, this one's near the high pressure gauge, a little bit different.
so the point being is that they can be all over the place because the bonnet is screwed onto the regulator, and they've already tapped the hole. Obviously, they're not going to tap the 1/8" bonnet vent after it's put on, and so wherever the hole ends up when they tighten it down and leak test it, that's just where the hole is going to be, anywhere in the 360-degree radius. So it's not consistently on the bottom, top, or sides.
Yeah, it's partly with the way they've machined. They use the CNC to do the bonnets, and it just isn't easily possible to get the holes in the same direction because you got threaded holes. You got the bonnets threaded.
Bonnet's threaded, and
the bonnet's threaded, and then you got to put a hole in here, and it just doesn't work that way. Now, the bonnet vent hole is for some people like to do with it. It's not going to. If there's a failure with a diaphragm, the gas is going to go through the bonnet vent hole. So if you're using a hazardous gas, some people like to pipe that away to an abatement system.
Well, they should always like to do that, and pipe away to safe location.
Or
flammable gases too.
Yes, for flammable gases, corrosive gases, toxic gases. They'll pipe it away, and I guess some people want to, whatever rig I don't know what they're doing, but yeah, some people like to have it in the same position. We get this question every now and then.
Well, I'm assuming if you're planning for it, you plan for the outlet here and it's straight out, and you're like, well, I got another outlet I got to worry about, 1/8". It's just, I can see why people would want to know that location. It makes sense. But yeah, it's sort of random. It's always on the bonnet, though. That much I can tell you. It will be on the bonnet.
The bonnet vent hole's
The
on the
bonnet vent hole will be on the bonnet.
Boy, that's good.
That's just...
Okay, now we're going to bring this back again. This is kind of like a bonus question in here. We have time for it. We had a customer had modified their switchover, and they had some leaks on it. And I'll kind of show you. This is normally you have it mounted here, but they actually, what they did, they had it mounted upside down. And they had the flex hoses. It is kind of. I didn't have time to get the picture. This came in like yesterday afternoon, kind of deal. So you get obviously flex hoses here go with their cylinders. Nice kind of hookup, but they couldn't see this gauge. So this gauge was rotated, was turned, was rotated like that, so they could see it from the top. That's what they did. It was screwed in there, and then this, they wanted to have this valve better, so this easier to get to from the top. So they rotated this up here to get to it, and then they say, hey, there's a leak, it's coming from the valve, I can feel it with my hand. Now, I know from experience, and you could hear it too, but it's hard to locate leaks by hearing, unless you got really good hearing.
Like a certified tracker, those people that on the movies that always they put
unless
their
you're in a
ear to the
movie,
ground.
you put and I know from experience, it's hard to find leaks with your hand. You can feel it leak, but I think that what happened was that they loosen this gauge, and it leaks coming from the gauge. And you put your hand over the valve and you go, oh, I feel the leak here, and maybe the leak's shooting from the gauge out. And you got that confused. So you suggested they use, we have a leak detector solution or bubble or something similar to that. Snoop,
that's it.
Not goop.
Not
Goop
goop.
6 things together.
Yeah.
So appropriate leak detecting solution.
The wrong general term for it.
And they could have messed up the valve by when they wrenched it into place. They could have messed it up somewhere there. So we do sell a repair kit for the valve. Comes with a stem and the.
Oh, so they moved the valve and the regulator.
Yeah, they moved the valve and the regulator, and I could tell that they moved that. Well, I know they retaped the valve, this whole valve assembly thing, because there was a lot of Teflon tape on there, and a lot of times customers overdo it with Teflon tape. But I couldn't see if they retaped it there.
If this much works, twice as much is twice as good, right?
Yeah. Exactly. Now with the gauge though, I mean the gauges are really tough to put in on a regulator because it's got to be, if it's not tight at that position, then you got to turn it in a whole another turn. Oof. Now there, it looks like they, like I said, backed it off, and if they didn't back it off, they would have had to turn it in like almost a full turn. And it's kind of like,
in order to get it to go back up, they're going to go full turn the other way, which is probably pretty difficult.
Yeah, and they're in the West Coast, and it was yesterday afternoon, so I didn't get any feedback yet from them.
I thought you were speaking disparagingly about people in the West
Coast. Nothing about that. It's just time-wise, it's a little bit hard to do.
No, I got you now. I was like, whoa, Bill, whoa.
They might have responded, and they responded, and I was already home or something.
Yeah.
I didn't see any response.
No, I always try to look at that because sometimes I'll accidentally call people at like 9 in the morning and it's California, and I'm like, oh, they're not going to pick up. I'll look for that.
I know. Well, that's all the questions we have for today. We actually have more questions, and we're going to try something different. We're going to do, we have these, you can get our Bill and Corey show on wherever you find your pretty much wherever you find your podcasts. So we're going to do we're going to call it Leftovers with Bill and Corey. So we're going to do a podcast tomorrow, and we're going to cover a couple of the questions that we didn't get to cover today, and we wanted to cover it. Because we do fresh questions every week. We wouldn't want to save these for next week because we'll get another batch of fresh questions. So we're thinking of maybe doing that. If we have extra questions we want to answer, we'll do that. So if you're looking for podcasts, we should have it posted tomorrow afternoon or something. So that's all we got for this week. Thanks for watching. Hope to see you again next week at 10 a.m. for another edition of the Bill and Corey Show.
Set your VCRs.